Okay, so quadratic formula is what we're going to do. Now, y'all probably seen this before, so hopefully it's not any something new that you'll probably see it and you go, oh yeah, I remember that. Basically, here's what it is. All right, if you remember, I think the last test we were doing, we had to do some factoring, we had to do some solving on that thing. That we had this part of it that we had to take this thing and break it down. We looked at all the shortcuts. If we were factoring, if the first term was one, we had a shortcut we could do. If this first term wasn't one, then we had to do the AC method, and then we had to break it down from there. So it's kind of along those same lines. And basically, this is one of those things that, let's say we've got a problem and it will not factor. It just doesn't work. So here's what your quadratic formula is. All right, now one little small thing we're going to add to the quadratic formula. When you plug in either A or B or C, we're going to put those in parentheses. And again, we will do almost all that in the calculator because that will kind of get us through everything that we're going to need. Again, the more parentheses we use, the easier it is to kind of not make mistakes as we're going through this thing. So that should help us out as we go through this. All right. And here's the big thing with this one. They got something they call the discriminant. And basically, that's the inside of our square root that we're looking at. So that's this b squared minus 4ac. All right, and the kind of the first thing we're going to do with this one is that if based on what this number is with this discriminant, what that answer is going to tell us how many solutions that we're looking for. So if the discriminant is, if you go back and do b squared minus 4ac, and again, that's where we're going to check it with a calculator. And again, if you check it on the calculator, the best thing to do is put the b and the a and the c in parentheses, because that way it will take care of any of the negatives that you have as you're working through this thing. But if you plug that in, if that number is greater than zero, if it's positive, you have two solutions. All right. And if you don't want to write discriminant in, just use your, parentheses there, your italics. So we'll do that. So if the discriminant is equal to zero, you have one solution. And if the discriminant is less than zero, you have no real solutions. All right, now here's where we tie in with what we've been doing the last couple of days, though. That if you don't have real solutions, you're going to have two imaginary or complex solutions. Okay. And depending on some of the problems will just ask you if it's 2, 1, or none. And then some of them will say, all right, go ahead and tell me what the answer is and tell me if it's got imaginary solutions or not. Okay, so what we're going to do maybe 2 or 3 examples where we're going to give you a problem. We're going to figure out what the discriminant is first, figure out what that number is, and then we're going to use that to figure out what solutions it is that we're looking for. All right, everybody good there? Everybody still writing that one down? Okay, so here's the directions we're going to use for the same, all three problems that we'll do. So we're going to use the discriminant to find or determine the number of solutions. Then we're going to find the solutions. Okay, so we're going to use the discriminant to tell me how many different solutions we're looking for. Are we looking for 2? Are we looking for 1? Or are we looking for no real solutions and 2 imaginary solutions? So we'll go ahead and kind of put that in as well, that if it's imaginary, so list imaginary solutions. Also, because sometimes on these they will just tell you to list the real number of solutions. We're going to go ahead and kind of do all those. We're going to list real or imaginary. So, all right, now the very first one we're going to do is we're going to make it really easy on it. Then we're going to get the next two that will be a little bit tougher, because we need an easy one to kind of start off with to make sure everybody's got the basics on what we're going to do, and then we'll crank it up and make it a little bit tougher after that. So we're going to do x squared plus 5x plus 6 equals 0. All right, here's where we're going to make it easy for what we can do. The a value is 1. The b value is 5. And then the c value is 6. All right, so the very first thing you want to, and this is pretty much the case, even if they don't ask you to talk about anything with the discriminant, if they just say to find the solutions, you still want to do the discriminant first. So even when they don't tell you to talk about the discriminant, still go ahead and do that part first. Again, that's b squared minus 4ac, but we're going to put the b and the a and the c in parentheses. Because if we have, now in this case, we don't have negatives, but if we had negatives, that would make a big difference on this part. All right, so it's going to be 6 squared minus 4 times 1 times, 5 squared. Look at the wrong number. 5 squared minus 4 times 1 times 6. All right, and again, as long as we're using parentheses correctly, you can punch that straight in on the calculator and make it 5 squared minus 4 times 1 times 6. So that is 5 minus 4 times 1 times 6. And that works out nice because that answer is just 1. Okay, so if it talks about the discriminant, we did b squared minus 4ac. Where does 1 fit? Is 1 greater than 0, equal to 0, or less than 0? Definitely greater than 0, right? It's positive. So in that case, we know we're going to have 2 solutions. So the discriminant in this case equals 1. So we're looking for 2 solutions. Okay, so some of these questions, that's the very first thing they're going to say is, all right, you use your discriminant to find out what this number is. So b squared minus 4ac is 1. And then you figure out, where does that fit? Is it greater than 0, equal to 0, or less than 0? So basically it's positive, 0, or negative, if you want to kind of break those down. So if it's positive, you have 2 solutions. If it's 0, you've got 1. If it's negative, then you don't have real solutions. We've got imaginary solutions that we've been working on the last couple of days with all the imaginary numbers. Okay, so we know we're looking for 2 real solutions for this thing. So then what we're going to do is we're going to take these numbers and plug it back into the quadratic formula. Now here's the good news though, is with this one. So if we write down the negative b plus or minus square root of b squared. We just write the formula down real quick that we've got it here. Here's the good news about doing this one with the discriminant. Here's the good thing about it, because some calculators will do all this stuff together, some won't. Everything that's on the inside of the parentheses, which is our discriminant, we've got this answer right here. So when we plug this in here, it's the square root of 1, because we found out what this number was. So then that makes that part of it really easy. And that's the hard. And on this one, the hardest thing is finding that number inside the square root and getting that one broken down. In this case, if we do it here, you've always got the number here, which makes life a little bit easier as you go through this thing. All right, so we're going to do the negative of b plus or minus that over 2 times the a. Well, b was 5, and the a value was 1. Okay, so again, this is the hardest part you've got to do, the b squared minus 4ac. This one works out nice because it's just the square root of 1. So that's just 1. It's negative 5. 2 times 1 is 2. Okay, now here's where you're probably going to have to break this apart and do it in 2 separate parts of this one, because calculators will not do the plus or minus at the same time. So here's where you got to kind of go 2 routes on this one. You're going to have to do one of these where you're going to do negative 5 plus 1 divided by 2. And you're going to have to do negative 5 minus 1 divided by 2. Because there is no plus minus, because it's going to give you 2 different answers. So when you've got the plus minus here, you're going to have to break it up 2 different times. So we're going to do negative 5 plus 1 divided by 2, then negative 5 minus 1 divided by 2. For this one, that is negative 4 divided by 2, which is negative 2. For this one, that is negative 6 divided by 2, which is negative 3. All right, and again, Math Excel more than likely is going to ask you just to put x equals. They're going to have a box here, so then we just do a negative 2 and then a negative 3. Okay, now that's if everything works out perfectly. And just wanted to show you that one so we can make sure we plug in the numbers so the numbers are easy to see and you can figure everything out that's there. All right, now we're going to do one when we do the square. And this worked out nice because when we did the square root of 1, it was just a number that was 1. We're going to do one where when we do this square root, it's not going to be a perfect square root. We're going to have to break this thing down so we can kind of see, what our options are going to be. But I want to show you that one just because, again, the numbers were easy and it worked out nice with this one to get what we want to do here. All right, so for example 2. We're going to do x squared minus 6x equals, scratch that, just make that equal 10. Okay, so very first thing, again, back up here, we were saying if we're going to do the quadratic formula, it's got to equal 0. So this is just like if we were solving by factoring. If we were going to do solve by factoring, this thing had to equal 0. So we're going to move this 10 from over here back over here. All right, and then once we're there, then you can figure out what your A and your B and your C values are. So A is 1, our B is negative 6, and our C is negative 10. So just like when we were trying to find the factors of C that equal the B term, the signs are really important because if you don't put the signs in there, you will not get the correct answer. So that's the one little thing we've got to do. All right, so very first thing we're going to do is we're going to do B squared minus 4 times A times C. So that is negative 6 squared minus 4 times 1 times negative 10. And yes, use your parentheses, because if you use your parentheses, there's a 99% chance you will not get the wrong answer. There's a 99% chance you get the correct answer. Again, that's just with the parentheses, just making that much of a difference. From there, it's just making sure you plug it in, and it all works when we plug it back in here. So we got negative 6 squared minus 4 times 1 times negative 10. So it comes out to be 76. Okay, and there may be a homework question where it may just ask you, what is the discriminant? In that case, the discriminant is 76. Again, the discriminant is just b squared minus 4ac. That equals 76, and then it's okay. Based on that number, how many solutions are we going to have? 76 is greater than 0 because it's positive, so again, we're looking for 2 solutions. Okay, so now we've got that, and again, that is the hardest part. Well, it's kind of a tie, I guess. Getting this number and breaking it down is kind of the hardest part. So from there, we're going to plug all this stuff in. We're going to need the negative of b plus or minus the square root of. Now, again, that's the discriminant, so that goes in here. And that's over 2 times a. So that's the negative of, and again, this is why we use the parentheses, because it's the negative of negative 6. That's over 2 times 1. Again, the whole reason we do the discriminant separate is that way. Again, if you try to do this on a calculator, it's not gonna. If you put all this stuff in, it's not gonna let you do that. It's gonna. There's too much stuff going on there. So we got to break it down into little pieces. So we're gonna do the inside of the square root first. Okay, the minus negative makes that a positive 6. 2 times 1 is 2. And then we're going to take this 76 we've got and we're going to break it down kind of like we did the other day. You want to do the stack method or the factor tree? Which one y'all like best? Tree? Okay, so if y'all want to go tree, we'll go tree. All right, so for 76, what are we going to do? It's even, right? So we can take 76 and divide it by 2. So take 76 and divide it by 2. And we got 38. 38 is also even, so we can take 38 and divide it by 2. And we get 19. If you start checking 19, 19 is a prime number. Against if you check it, it won't divide by 3, it won't divide by 5, it doesn't divide by 7. So in that case, there's our prime numbers at 2, 2, and 9. So if 76, we're taking square root of 76 and breaking it down, 2 times 2 times 9. The pair of 2's is our exit buddies. So the 2 gets out, the 19 will stay on the inside. Okay, so when we're doing square root of 76 that we had here, we're going to make that 2 square root of 19. All right, now here's the part at the end where we got to kind of go one more step. The way this one's set up, you've got to simplify that. If this 19 wasn't here, then basically we can think about this like being an x for just a minute. Yeah, so we had an x that was here. This would be like 2x. So we've got to try to simplify this thing. So what we're going to have to do is go down to the next page here because we're around the room. We're going to break this thing up. So we're going to do 6 divided by 2. So we're going to do the first parentheses. We're going to do the first part. We're going to divide it by 2. And then we're going to do the second part. And then divide it by 2. Okay, so that is 3 plus or minus, those two cancels, square root of 19. Okay, and if you're writing your answer, you can put that plus or minus. So for that one, that would be done. And they will tell you probably in that case to leave the answer in radical form, for what you're doing. And again, if you wanted it as like two separate answers, one answer would be 3 plus the square root of 19. The other answer would be 3 minus the square root of 19. Okay, one more example, and then one other tiny little example, and then we'll be done. Okay, so you got 3x squared minus x plus 5. Now, and some people may say, ooh, could we factor that one? Kind of like we're doing on the last test. Could we do the 3 times the 5 and get 15 and try to find the factors of positive 15 where the sum would equal negative 1? You can try that, but if you check your factors, there's only 1 and 15 and 3 and 5. There's no way you can put a positive or negative in here anywhere and get a negative 1, so this thing does not factor. And that's basically what happens is that you use the quadratic formula when you've got something that doesn't factor. Because I'm going to tell you back here. And again, we did this one on purpose this way, but we actually could have factored this one, the very first one we did. You could have found the factors of 6 to equal 5. That one would have been 2 and 3. And then you could have solved that one from there. But again, the main thing we were doing in this case was just the practice on it. So we tried to give you an easy one to practice to make sure we had it. But I would say on these problems, if you find one you can factor, try to factor because it'll be a lot faster than the quadratic formula. Okay, so it doesn't factor. So A is 3, the B is negative 1, and then the C is 5. All right, so again, if we go for the discriminant, it's B squared minus 4 times A times C. So that is negative 1 squared minus 4 times 3 times 5. All right, and then checking that one, we're going to get times 4 times 3 times 5. We get a negative 59. Okay, and then again, the whole purpose of doing this one is that we figure out, all right, based on what the discriminant is, that tells us how many solutions we're looking for. In this case, it's negative, so we're not going to get any real solutions. So there's no real solutions, but there's 2 imaginary solutions. Because some of the problems, they may say if there's no real solutions, then it may just be that that's all you're going to do. You're just going to stop there. We're going to go ahead and do one where we've got the imaginary because it's just, going one more step here to kind of get what we need. Because this will be the last one that we'll do today as far as a full-blown example goes. Okay, so we know there's not going to be any real solutions off this thing. Basically, it means when we do this thing, we're going to have an answer back here where we're going to have to put an I because we're going to have a negative square root that's here. So that's basically what that means as we go through this part. All right, so we plug in our numbers. We've got the negative of B, which is a negative 1, plus or minus the square root of negative 59 over 2 times A, which was 3. Okay, and then we're going to take the 59 over here and we're going to try to break it down. Again, it's odd numbers, so we start checking all the odd numbers. Pick 59 divided by 3. That's not going to go. It doesn't end in 0 or 5, so no 5 is not going to go. You check 59 and divide it by 7. That doesn't go. If you check 59 divided by 9, that doesn't go. If you check 59 divided by 11, that doesn't go. If you start checking all the odd, none of them go into it evenly. So that means that 59 is just prime, which means we cannot break it down. So that's just it. I mean, there's nothing you can do to break that 59 down. So it's just going to stay that way. So all we're going to do is we're going to fix the minus negative, make that a positive 1. The 2 times 3 on the bottom is 6. And with the negative 59, this is where we're going to get the complex number. So we're going to do the square root of 59. Okay, and what we mentioned yesterday was if you've got a negative number with the square root, you've got to make sure that if you put the I here, that it's not inside this. It's got to be on the outside of that 59. So that'd be something kind of like that. Now, what I have seen some people that will do, just to make sure that you know it's not on the inside, I have seen books do like that, where they'll put the I in front of the square root. That way they know it's not on the inside. And that's the big thing is the I has to be outside of the square root. It just cannot be on the inside. Okay. Now, one thing I've seen that Math Excel does, and I don't like that they do it this way. Sometimes they get these and they'll say, all right, don't make it one big fraction like this. They want you to make it so it's like 2 separate fractions like this. And I wish this one they would just leave it there. But just in case they say this is wrong, what you would have to do is you'd have to go back and change this to 1 over 6 plus or minus I times the square root of 59 over 6. So, and that would be one if we were doing an online test, which may possibly happen with the next test coming up. If they gave you this one and they counted this wrong, that's one where you could just tell me, hey, I had the correct answer. They counted it wrong. I'd go back in and give you credit for it because there's no need of breaking this one up because nothing simplifies. So this should be fine or that one. So I'm okay either way. But I think Math Excel a lot of times will make you go this route where this is still a good answer for this part. All right, one more quick one, and then we're done. Okay, so let's say we've got 2x squared minus 4x plus 2 equals 0. All right, A is 2, B is negative 4, and C is 2. So again, if we do B squared minus 4 times A times C, check that real quick. We get a nice, easy 0 for that one. Okay, so the discriminant is 0, which means we only get one solution. All right, and if you're doing these, this is where you kind of want this to work out because this is where it works out kind of nice and easy because if you take these numbers and plug it back into the quadratic formula, it's the negative of B plus or minus the square root of 0 over 2 times A. All right, but here's the good thing about this one. If you do the square root of 0, that's just 0, right? which means if you square root 0 and you add 0 or you subtract 0, that doesn't do anything at all. So when you've got this plus or minus 0, it's just gone. So the only solution that you're looking for is the negative of b over 2 times a. So that's 4 over 4. So in that case, your x, again, this is your x that you're looking for your solution here. That means that you have x equals 1. Okay, and I forgot to do that back here. When you get these solutions, these are always x equals. So in those solutions we get. So in this case, the one solution we had worked out to be that the solution was 1. And does anybody remember when we did negative b over 2a? When did we start doing that stuff way back when? We used a negative b over 2a to find the, what did we use the negative b over 2a to get when we were doing some graphing a while back? Anybody remember? We had to find the vertex. We had to find negative b over 2a and take that number and plug it back in. So it all ties together with the factoring and the graphing and all that stuff. That this is basically helping us find out what the vertex is if we did negative b over 2a.